Okay, we'll be constructing the Lewis structure for this molecule, N2H2. First off, let's figure out how many valence electrons will be contributed by each atom to the molecule by looking at the periodic table. So we see we have 2 nitrogen. They fall into group 15, so they will contribute 5 electrons each. We have 2 hydrogens fall into group 1, so it'll be plus 2, because plus 1, that'll be 12. So this is our supply, which will be right here. So what is our electron demand? Our electron demand is to satisfy each element by the octet rule, except for hydrogen, because they follow the duet rule. So nitrogen needs 8, nitrogen needs 8, hydrogen needs 2, hydrogen needs 2. So what we'll do 2 plus 8, which is 10, 10 plus 8, which is 18, 18 plus 2 is 20. So 20 is our electron demand, and once again, our supply is 12. 20 minus 12 is 8, divide that by 2, it gives us 4. So we need 4 bonds. So we know each of these hydrogens will only get a single bond, so we will have 2 bonds remaining, so we'll put 2 bonds right there. So we'll have 1, 2, 3, 4, correct, but we need to satisfy the octet rule. So we'll give each nitrogen a lone pair of electrons. So we'll have 2, 4, 6, 8, 10, 12. Checks out. And then, yep, octet, octet, duet, duet. So let's check the formal charges. Nitrogen has 5 valence. We have a pair of non-bonding, which is a total of 2 lone electrons. And we have how many bonds? We have a bond here, and a bond here. So a double bond counts as 2, so 2 plus 1 is 3. So that equals 0. And we have the same thing on this case. We'll have 5 minus 2 plus a double bond and a single bond equals 3. You can just think of it counting the lines. So that'll give us 0. And hydrogen is in group 1. It has 0 lone pairs and has a single bond. So that equals 0. And we can see that this hydrogen is also 0. So this is the correct Lewis structure for N2H2.